Okay, so we've got an integral here, 1 over sine x with respect to x from pi over 4 to pi over 2. Now this looks quite like an innocent integral here, but it's got lots of problems involved in trying to integrate this function. Luckily our range is pi over 4 to pi over 2. This function exists over that range, but if we had some zeros in there we would be struggling with our parameters. Also if we have pi in there we'd also be struggling. The limit of this function does not exist at that place. So moving on, we've got pi over 4 to pi over 2 as our range. That's great. And we know 1 over sine x is the cosecant function. So just to integrate this off from there, we can't do it. We know sine of x is integrated to be negative cosine of x. That's fine. But we can't really go that route because it's the reciprocal. So we need to find some sort of u substitution. So what u substitution are we going to do? Well, first of all, let's take the derivative of cosecant of x, because when we do our u sub, we need to take the derivative of our u. So let's try and take the derivative of this. So the derivative with respect to x of 1 over sine of x. Now this is a usual reciprocal rule for derivatives. So the reciprocal rule is we get the negative and then square the bottom term and then the derivative of the bottom term, which is cosine of x. So that's our derivative. So what have we got here? We've got negative cosine of x over sine of x times 1 over sine of x. So it looks like we've got negative cotangent function multiplied by 1 over sine of x, which we know is cosecant. So that's our derivative here. Now if we take the derivative of that, we're going to get some more functions come up. So why don't we try cotangent of x plus cosecant of x? Let's try that. So let's try u equals cotangent of x plus cosecant of x, and let's see where that takes us. So we're going to need to take the derivative of this, so let's work out the derivative of the cotangent function. So d dx of the cotangent, which is the reciprocal of the tangent function, which we just did here, so we know our reciprocal rule will come in good again. So 1 over tangent x, so again negative 1 over tangent squared of x, and the derivative of tangent x, famous derivative, is secant squared of x. So I'm just going to change this 1 to secant squared of x. Now that looks a little bit too intimidating for me to put into an integral, so we're going to try and simplify this off. So secant squared of x, we know that is negative 1 over cosine squared of x, including the minus sign, and tangent squared, well that's in the denominator, so we need to write that as sine squared of x over cosine squared of x. And that's pretty handy. We've got a cosine squared there and there, we could just cancel them out. That is all legit. So now our derivative here equals negative 1 over sine squared of x, which is the same as the negative cosecant squared of x. So that's that taken care of. So now we can plug in our du. So we've got negative cosecant squared of x, and we're going to have to add this one on. Well, we've got a minus sign here, so why don't we bracket it and put a plus sign, then we can distribute that minus sign in there with cotangent of x times cosecant of x. Okay, that's great. So now we've got our du, and then there's our, obviously our dx has to go on the end there. Okay, so I'm going to take these u's and du's, put them on the side here, clear the board and make things look a little bit tidier, and then we'll try transferring this integral into the u world. Okay, next thing I'm going to do is I'm going to change our parameters. Doing the u sub you don't have to, because you can always plug back in, but with this integral, with these numbers, I think I'm going to go straight into the U world with my parameters of integration, and that way then I'm straight ready for my answer when I get my integral. So let's have a look at the pi over 2. So if x equals pi over 2, we need to find what our u is. So our u will equal whatever the values of x are in this u. So we need to plug in pi over 2 into this. So cotangent pi over 2 plus cosecant pi over 2. Okay, well, cotangent pi over 2 we know is cosine of pi over 2 divided by sine of pi over 2. Now cosine of pi over 2 we know is 0, so we're going to get a 0 over 1 situation there. Sine of pi over 2 we know is 1. Now what about cosecant pi over 2? So cosecant we know is 1 over sine, and our value will be pi over 2. Well, we know from here that it's 1, so we've got 1 over 1, so that equals 1. So we've got a 0 plus 1, 0 plus 1, it's going to write a 0 plus 1 there, so then that equals 1. Okay, let's take these ones off the board, and then let's work out our pi over 4 situation. So for x equals pi over 4, our u substitution will be u equals cotangent pi over 4 plus cosecant pi over 4. Now again, cotangent we know is cosine over sine, so cosine pi over 4 divided by sine pi over 4. Well, we know that these two values are equal. They are both root 2 over 2 divided by root 2 over 2. So that's just going to give us a 1. So that's a 1 there. And then cosecant pi over 4. So that's 1 over sine pi over 4. Well, sine pi over 4 we've got in here, which is 1 over root 2 over 2. So that's going to be a 2 over root 2. Okay, so cosecant pi over 4, root 2 over 2, reciprocal of 2 over root 2. So that's then going to give me 1 plus 2 over root 2. Okay, so now let's plug our values up here. Okay, so we've got here our 1 over sine x, which is cosecant of x. We can't plug in u yet because that's not actually in our integrand. So we need to try and get this in our integrand somehow. So what I'm going to do is, if I get cotangent of x plus cosecant of x and divide that by cotangent of x plus cosecant of x, that's 1. So if I plug that into the integrand and multiplied everything by that, if I multiply by 1, I'm not changing it. So let's do that, and then we've got that, we'll be ready to go into the U world and use all of our new parameters. So let's just change this up now. So pi over 2, pi over 4. So we're still in the x world for now. So cosecant of x, and then multiply this by what's going to be our u. So cotangent of x plus cosecant of x. And again, divide that all up. Okay, so now let's transfer this into our U world with a little bit of simplification as we go along. Let's see what we can do. So we can change our parameters. So we're going to need a bit of space here. So u equals 1, and u equals 1 plus 2 over root 2. And then we've got cosecant of x times all these. And divide that all by cotangent of x plus cosecant of x. Now our dx, let me just put that dx back in there, that's breaking all the rules. So our dx we know is going to be this. So let's just write this in there for now. So our minus sign, I'm just going to bring that out front. That's fully legit. And now I'm going to put my du, and I'm going to divide it by this. So I've got cosecant squared x plus cotangent x cosecant x. Now I can change that. I can write that now as factoring out cosecant of x. So I can now do cosecant of x and then multiply that by cosecant of x plus cotangent of x. Now that looks a little bit intimidating. There's a lot of stuff there, but you'll see there now, there's loads of cancellations we can do, and this simplifies up massively. So this and this is going to cancel out. Obviously these aren't allowed in the U world, we need to take them out. But I'll put them in there so you can see the cancellations. So that cancels out with that, and that's great. And this cotangent x plus cosecant x, hey presto, that's our U. So that becomes a 1, that becomes a 1, and this becomes a U. So now we're ready to rewrite our integral, and how much simplified it's going to look. It's going to be really good. So now write this off over here. So we've now got negative 1 over U du. And then our parameters, 1 plus 2 over root 2 and 1. That's our parameters. How much simplified does that look? From starting from this and all this working out, also now we've got a really famous integral. We all know what this one is. This is the negative log of U. So negative log, the natural log that is, of U. Now as we're dealing with trig functions, we are going to need our absolute value. So let's not forget to put our absolute values in there. Okay, and now we calculate this over our range of integration, which is from 1 to 1 plus 2 over root 2. So we're looking here, we've got 1 plus 2 over root 2 and 1. So it looks like this one here is going to be the larger one. But anyway, we can still carry on. We could either switch them round and change that negative, or we can just persevere with what we got. While we've got this far, I'm just going to persevere with what we got. So you could try the other way around if you wish. So I'm going to now go negative log of U, which is negative log of 1. So negative ln 1. And then we're going to subtract our next bit, which is negative natural log. So now I'm going to put my absolute value. Just cheated a little bit there because I know natural log of 1 is going to be 0. 1 plus 2 over root 2. And I'll put my natural log in there, but I know I don't need it. Okay, so now what we got? Natural log of 1, we know this is a 0. And then 2 negatives, obviously we know that is a plus. And then we've got natural log of the absolute value. Well, we know this is going to be positive, so I can now go back to standard brackets. 1 plus 2 over root 2. That is going to be our answer to this integral. And if you plug that into your calculator, you'll get an approximate value of 0.881375 decimal places. So plug that in, you'll get something like that, but that's the exact value. Okay.